we need to talk a little bit about some notation that you're going to see. So we've used the word and or. In the last video, we talked about what's the probability of this and this happening, and then what's the probability of this or this happening. And you're going to see some notation to show that. So when we're saying and, we use this symbol right here. It's like that. That's the intersection. So it basically means the intersection of the two circles, right? And just know, I always think of this, honestly, this is super cheesy, I know, but I think of it as like a little A. And so it's just and. Like I just think of it as an A. So yeah, it means and, okay? So that's the probability of both things happening. So when you have an event, what's the probability of the person being a freshman and female? Okay? That's and. This one, this is the union, and this is or. So it's what's the probability of the person being a freshman or a female? Okay, so we would look at the probability of either or happening, which also means, remember in our last one, we can say both, right? So someone can be a freshman and a female, or they can be just a freshman, or they can be just female. All of those people would qualify for the or distinction, right? Because we're talking about everyone who's female and everybody who's a freshman. Okay. And then it didn't show up on here. This with the line above it means what's the probability of not A. Okay, so it's going to have like a line above it. And so that would mean, like, if I said, what's the probability of not 1, right? And I'm rolling a dice. What's the probability of me not getting a 1? Well, there'd be 5 other options that would be not a 1, right? So that would be 5 out of 6. The probability of not 1 would be 5 out of 6. Or if the event A is being female, then the probability of not A would be being what's the probability of someone not being a female, So what about the probability of, what if I said probability of A and not A and B? Not A and B. See the lines across the entire thing. So it's like the opposite of A and B. So if A and B is this intersection of the two circles, right? Then not A and B would be everything else, right? So the probability of not A and B would be everything around. Okay, so let's look at an example with this. We're going to, they surveyed 53 students at the school, and they found that all of this information. 11 people played volleyball, 8 people played basketball, 2 people played all 3 sports, 4 played both basketball and softball, 7 played volleyball and basketball, 12 played softball, and 5 played softball and volleyball. Okay, so then we draw a Venn diagram. I already have it drawn, but again, I'm just going to draw it again so you guys can see the process. So we're going to do the green is going to be basketball. Yep, the green is basketball. The purple is volleyball, and the red is softball. And you see, they can intersect, right? Because someone can play all 3 of those sports, right? If I said volleyball and football, those happen at the same time, so you couldn't intersect. They would have no intersection, right? Okay. So then we just fill it in with the information we know. It says 11 people played only volleyball, and we can just fill this in. Use the magic of video. So this right here between the purple and the green would mean people who played volleyball and basketball, right? But it's not inside the red circle. So we'd have the 7 people who played those 2 but did not play softball would be here. And then this where all 3 of them meet is going to be the 2 students who play all 3 sports and so on and so forth. Now, you make sure you draw the box around because we surveyed 53 students, right? We surveyed 53 students. If we add all of these up, that doesn't equal 53. In fact, it equals 49. So where's the other 4 students? Well, those would be the students that don't play anything, right? That's totally possible that we have somebody who doesn't do any of these sports. So those people are going to be out here. So we have 4 people out here, 12 people in here, and so on and so forth. Okay, so probability of A means what is the probability of A happening? Or in other words, if we pick a random student, what is the probability that they play volleyball? So A is volleyball. It's the purple one, right? And what is the probability that someone plays volleyball? If we just pick a random student out of these 53, what's the chance that we're going to pick one that plays volleyball? Remember, probability is favorable outcomes over total outcomes. So how many students would be a favorable outcome? If I picked them, they would be favorable, which means they play volleyball. Well, you're thinking maybe, oh, just 11. But wait, there's more. There are students who play more sports. They play volleyball, but they play other sports too. So everyone inside this purple is going to count. So we have 11 plus 7 plus 2 plus 5, which gives us 25 students that play volleyball altogether. And so our probability of A would be 25 out of 53. So using the same Venn diagram, we can answer some questions. So again, remember this 12 here means that if I wrote my sample space out, I would have 12 different places where I said someone that plays only softball, right? And if I wrote my sample space out, I'd have 11 people who I wrote out plays only volleyball. Okay, so what is the probability that they do not play volleyball? And apparently none of my little notations that I put in here showed up. I didn't know that. Okay, so not volleyball would be probability of A with a line over it. We say A, not A, the probability of not A. So this is everybody that doesn't play volleyball. So it would be just everyone that's not inside the green circle. So it'd be 8 plus 4 plus 12 plus 4, right? It'd be everybody that isn't in there. So we'd have 28 over 53. What's the probability that they play basketball? So it'd be everyone inside the purple, 8 plus 7 plus 2 plus 4. What's the probability of softball? And everyone inside the red, including these people who play both or 3 sports, right? So 5 plus 2 plus 4 plus 12. What is the probability they play volleyball and basketball? So then we would come here. Volleyball is the green. Basketball is the purple. So everywhere that they cross is going to count. So you're thinking, okay, there's the 7 people who play just volleyball and basketball. But don't forget about these 2 people that play volleyball, basketball, and softball. So these guys count too. So we would have 9, right? Because that's, if you can imagine, it's almost like you have to go cross-eyed a little. You're like, okay, cross-eyed, and only look at the purple and the green. It's almost like you can forget that the red even exists and look at just the purple and the green, okay? That was kind of a ridiculous way to do it, but you know what I'm saying. All right, so what if they play volleyball or basketball? Now we're talking about everyone, not just these people right here in the middle. We're talking about everyone inside the green and everyone inside the purple. So we're going to add all of these. 11 plus 5 plus 7 plus 2 plus 4 plus 8. Okay, we're talking about everybody inside of either one of those because we're talking or. Here, the line showed up. Okay, so what if we said they did not play volleyball and basketball? So this line again means not. Okay, so we're talking about everyone except the people in this middle right here. We're not talking about these people in the middle. So everyone except that. So we just add up all of those numbers. We get 44. What if they play volleyball or basketball? Did we already talk about that? I feel like we did. Not play volleyball or basketball. Okay, so this is everybody that is not inside of the green or inside of the purple. So it's only the people down here, this 12 and the 4. Everybody else is inside either the purple or the green. Okay, so we don't count them. What if we ask how many people play softball or volleyball? That would be everyone inside the green circle and everyone inside the red circle. Okay, so we're going to have 11 and 7 and 2 and 5 and 12 and 4. What if we said not play volleyball or softball? So that's, we take out, imagine, cross your eyes and imagine that this circle disappears and this circle disappears. What do we have left? We have 8 and we have 4. What if we said who plays all 3? Okay, so you see how this is an intersection between all 3? Probability of A and B and C. Okay, that means all 3 of them together, and there's only 2 people that are in there. What if we said not play volleyball, softball, and basketball? Again, we kind of cross our eyes and pretend like this little circle doesn't exist. We're looking at everyone except that circle. So it's going to add up all of those. And you could figure that out without adding them up because you could figure out, well, it's everybody except for 2 people, right? Let's see. Finally, play volleyball, softball, or basketball. Okay, so you might be able to figure this out. If you look at this, play volleyball, softball, or basketball. That's anybody who plays any of these sports. How many people don't play the sports? Well, there's 4 of them, right? So 53 minus 4 would be 49. Or you could just add all of these up, right? We're just going to add up every single person that is inside of some sport, and we're going to end up with a probability of 49 out of 53. If I just randomly picked a student, I would have a 49 out of 53 chance that I picked a student who played one of these 3 sports. And then the final one, see this line over the top? The U's, the little U's are the union, and that means or. So I'm saying the line means not volleyball, basketball, or softball. And how many people don't play any of them at all? That would be 4 out of 53.